Welcome back.
Hi everybody, welcome back.
We are getting so close to being done.
Can you feel it? Okay, so today we're going to talk about solving trigonometry equations.
This is actually in 5.1, 5.2, 5.3, and 5.4.
But we smushed it all together because it makes more sense this way.
Much more sense, at least to us.
We've given you some hints on your notes over here. So read through those. Basically, you want to think of all your algebra rules. And this is the most important part of that. You need to be able to give the correct solutions. Okay? And that's going to be based on the directions and the context of the problem.
And we're going to have a lot of squared trig functions involved. So just like quadratic equations where there were other ways to do things, if x squared's by itself, get it by itself. Or if x squared's the only thing in the problem, get it by itself. And other things along those lines. Factoring is going to come into play. All kinds of different ways that we solve quadratic equations. They're all coming back.
Yep, the zero product property. We did that in Algebra 1 the other day.
Absolutely.
All right, let's get into some examples here.
All right, you're up first.
Okay, my turn. We need to solve the equation for 0 to 2 pi.
What does that mean?
That basically means give me any answers where it's true on one trip around the unit circle. Actually, it would be this way to you. Okay, one trip around the unit circle. So when we look at this, we see a tangent squared and a single tangent. Again, you can always go back to Algebra 1 and think of this in terms of something that looks like this. If you saw that equation a squared plus a, what would you do?
I'd factor out an a.
Okay, so let's factor out a tangent.
Sounds good.
So we're going to factor out a tangent of x, and we're going to have a tangent of x
Plus 1.
plus
Don't forget that.
1. When you factor, you are undoing distributive property. Okay, the zero product in a nutshell says if you're multiplying two things and the answer is 0,
one of them got to be 0.
one of them's got to be 0. So either the tangent of x is 0 or the tangent of x plus 1 is 0. Okay, so if we're going to solve each of these separately, when on a unit circle is the tangent 0?
Well, tangent is 0 when, well, at 0 and pi, they're the same place as sine would be 0.
Right, whenever sine is 0. So when we are over here or when we are over here. So all we know right now, simple as that x either equals 0 or x equals pi.
You have two answers so far?
Two answers so far. You've done this already, by the way. Okay, second side, let's take a look over here. We've got the tangent of x plus 1. Tangent is not by itself yet, so we're solving. We're getting the variable or the tangent trig equation by itself. We want to know when does the tangent of x equal negative 1?
Well, tangent would equal 1 at a 45-degree angle, so it must be in a different quadrant than 1 or 3.
Okay, so let's review our quadrants. All students take classes. Okay, so if we want tangent to be negative, we must be in quadrant
2 or 4.
2 or 4. We still have the same reference angle, which was 45 or pi over 4. So what is our angle?
That's going to be 3 pi over 4.
It's going to be 3 pi over 4. And in the fourth quadrant?
7 pi over 4.
7 pi over 4.
So you're telling me we have 4 answers for this problem?
We have 4 answers. We have 2 answers for that factor, and we have 2 answers for that factor. If we take any of those answers and we plug them back in right here, oh, that's not a highlighter, is it?
No, not usually.
Okay, where's the highlighter? There we go. If we plug them back in right here and right here, we should get 0.
You know, they could also take out your calculator and graph tangent squared of x plus tangent of x and y1. Set your window for x to be x min 0, x max 2 pi, and you'd actually see that it crosses the x-axis 4 times between 0 and 2 pi.
Yep. So
once at the beginning.
Changing of your window there. Come and ask us if you want some help on how to check that. Okay? All right, let's try another one. Let's say, this is example. Oh, 1b, I got it. I was like, this is example 2. Okay.
I just kept writing the examples over and over again.
All right, so this time we've got 2 sine squared minus 5 sine x plus 2. Again, go back to anytime you see a sign, use a different letter. So if I've got 2y squared minus 5y's plus 2, we need to be able to factor this. Most of us do that with a box. Okay, so we've got 2y squared plus 2. I need the factors of 4 that add to be negative 5. Hopefully you can do some of that in your head by now. It's negative 4 and negative 1. We're going to take out a GCF of 2y. Okay, so when I factor the blue stuff, I get y minus 2 times 2y minus 1. What does that mean in trig world?
Well, everywhere there's a y, just put a sign of x.
Okay, so that means we're going to have the sine of x minus 2 times this sine, I'm sorry, 2 sines.
You tried to erase with your finger.
I did. Works on my board that way.
2 sine of x minus 1, and the whole thing equals 0.
Yes, it does. So again,
try not to forget to write that part down.
That is important. You are solving an equation. Okay.
So the first parentheses means the sine of x minus 2 equals 0,
yes,
or?
It does. The sine of x equals 2. Now wait a minute. Well, actually, I'm going to go ahead and write both of these first so I don't lose track that there's two of them. 2 sine of x minus 1 equals 0. We're going to go ahead and solve that and get...
Add 1, divide by 2, we get 1/2.
Okay, so back to this first one here. When does the sine of x equal 2?
Well, the sine function goes up to 1 and then down to -1 over and over and over again, but it never actually reaches 2. So never.
Never. That one's irrelevant. Gives us no solution on that side. So let's come over here and talk about the sine of x equaling 1/2.
Well, that would be a 30-degree reference angle.
Yes, it would. So in the first quadrant, we would be at
Pi over 6.
pi over 6.
And in the second quadrant.
Not the second. Oh, I'm sorry. I hate it when he's right.
Oops.
I guess it is a sine, isn't it? So back to all students. Take classes. In the second quadrant, we have a positive sign way over there.
5 pi over 6.
5 pi over 6. So all we're doing is giving us answers where this happens on one trip around the unit circle.
Just one?
Just one trip around.
All right.
We're not including the 2 pi because the 0 and the 2 pi are going to give you the same answer.
That's going to be important in a minute.
Okay. Mr. Lecky's turn.
Awesome. Give me the one that has all weird stuff on it, huh? All right.
Yep.
I'm still solving for the interval 0 to 2 pi, but I've got sine of 2x, and I've got 2 cosine of x. Now, there's a couple of things to realize. The first and most important thing is that this function has a 2x in it, and this function has an x in it. And if possible, it's going to be a lot easier to do these problems if they both have the same input, if you will.
Yes, they both need to be an x.
So we really can't turn cosine of x into anything, but we can turn sine of 2x using an identity.
That was a double angle. We learned that last class or a couple
In
classes
theory,
ago.
sine of 2x turns out to be 2 sine of x
Cosine of x.
cosine of x, and it equals 2 cosine of x.
Hey, Mr. Lecky, can we just cancel the cosines?
No.
No.
In order to cancel them, it would require you to divide. And if you divide by something that's not 0, it's allowed. But cosine of x is basically has a variable in it, and anytime cosine of x was 0, you would divide it by 0, pretty much ending the world. Bad things happen. All right, black holes, bad things. World comes to the end. Mayan calendar happens. All that fun stuff. Okay, so we need to, instead of dividing by the cosine, we need to set this equal to 0 and do some factoring.
Okay,
All
so
right.
minus the 2 cosine?
So we're going to minus 2 cosine of x from both sides. So we're going to end up with 2 sine of x cosine of x minus 2 cosine of x, and the whole thing will equal 0.
Actually, it's a cosine of x.
Well,
See, I'm
yeah,
not the
there's
only one making
there's an
mistakes
X in
today.
there?
There's
Weird.
an x in there.
That's just wrong. I think I started off by putting the equal sign in the wrong place off the bat. All right, now that I got
That's
it.
pretty. Good
All
job.
right.
Okay, let's factor.
I can do math. Factor, we have a common factor of 2 cosine x in both of them.
Okay,
We're going to go ahead and take that out.
so I have 2 cosine of x times sine x
Sine
minus
sine
1.
of x, and then don't forget the minus 1.
Okay, so even though there's 2 different trig functions here, this works kind of nice because they're separated.
They are separated. I have this times this equals 0, so one of them has to be 0. So either 2 cosine x equals 0,
Okay,
or sine of x minus 1 has to equal 0.
okay,
So if we take care of the first one, we divide by 2, and cosine of x has to equal 0.
yes it does.
Where does that occur?
That occurs on the y-axis. So let's go with pi over 2
Pi over 2
and 3 pi over 2.
and 3 pi over 2. You can use your unit circle. You could use the graph of cosine if you wanted to. And that's supposed to be a pi.
Who oriented this more?
Not me. There's always one portion of the board that doesn't work out perfect. You ever notice that?
No.
All right. Sine of x minus 1 equals 0 means that sine of x would equal 1.
Yes, it would.
And where does that happen?
That also happens on the y-axis at pi over 2.
That's at pi over 2. And at 3 pi over 2, it would have been negative 1, correct?
Correct.
So we have 2 answers here for x, and we have another one that's just repeated. We call that multiplicity of 2, don't we?
We do call that
Awesome.
multiplicity.
It all-
We don't have to remember that, do we?
Not for now, but
Okay.
you know, it all comes back to haunt you later. All right, anyway, but no, the answers are just pi over 2 and 3 pi over 2 for x. Our second parentheses there just got a same multiple answer of the first one. So we're good to go.
Okay.
3 more examples and we're out of here. The only thing different is the directions. I'll go ahead and tackle the first one.
Okay.
Okay? The directions here are find all real solutions. We are not just limiting our world to 0 to 2 pi. But what we're going to do to make this easier for you is we're going to tell you to find all the answers from 0 to 2 pi anyway, and we're going to show you how to adjust the answers to represent all of them.
So it works the same way solving it.
Same exact process, okay?
Okay.
So this is the same thing. Think of this as just 3 more examples of doing the same thing. In this problem, I have 2 sine squared of x minus 1 equals 0, and again, we'll go with this idea of changing the letter if all I had was 2a squared minus 1,
Can't you just get a squared by itself?
I can. And then I take a square root, and don't forget the plus or minus in your answer.
Right.
So we're going to isolate the sine squared of x part first.
Okay, so
We're
we're
gonna
gonna
add
add
one.
1, divide by 2, and we just
Divide
make it
both
1
sides
half?
by 2, and we get sine squared of x equals 1 half.
Okay,
How do I get rid of a squared?
we square root.
We square root both sides. This is where you cannot forget about the plus or minus. Sine of x is going to equal plus or minus the square root of 1 half,
Well, isn't that the square root of 1 over the square root of 2?
which is square root of 1 is 1, and the square root of 2 is just the square root of 2.
Okay, hey, that looks like one of our special numbers.
That's also that idea of square root of 2 over 2, isn't it?
Yes, it is.
So either way you want to think about it.
Either way.
So what angles does that come from for sine of x? Just on the unit circle, one trip around.
Okay, well, it's any multiple of 45 degrees or pi over 4.
Right. The plus and minus here literally just tells me I can be in all 4 quadrants.
Right.
So I can have a 45-degree angle in quadrant 1, a 45-degree angle in quadrant 2, quadrant 3, or quadrant 4.
So how about pi over 4?
Pi over 4, let me get rid of this silly picture because I'm going to need my space.
Yes, you will.
X equals pi over 4.
3 pi over 4.
It could also equal 3 pi over 4,
It could also equal 5 pi over 4,
5 pi over 4,
and 7 pi over 4.
and 7 pi over 4. Now, that would be if I limited my world from 0 to 2 pi and went one trip around the circle,
Okay.
correct?
So if the directions were like example 1, we'd stop there.
Correct.
Okay, but
Now-
what's this all stuff?
Well, let's just take a look at this real quick. We'll go through this faster for the other ones, but a sine function doesn't stop at 0 to 2 pi, does it?
It doesn't. It goes, every period it repeats.
And if I wanted to 1 half, that would be 1 half, because this is 1 up here.
Okay,
It actually hits a sine function quite a bit,
actually infinitely many times.
an infinite number. But it also hits negative 1 half an infinite number of times.
Oh man, we have to list all those?
Every one of them.
Is
See
there an
in,
easier way?
in a few lifetimes. Yeah, we can't list them all, but we can list a way to generate all of those answers.
Okay, so wait a minute. Every time I go around the unit circle and I land on a multiple of pi over 4,
So let's say just take pi over 4 for the
Okay.
first one. If I'm here, I went to there.
correct.
If I go around the unit circle one whole time in the positive direction, I will actually land at 9 pi over 4.
Right.
But that's one more trip around the unit circle.
So that's 2 pi units more?
Yep. And if I go again, that's 2 more pi.
Okay.
And I've still got my same answer.
So we just have to do whole jumps of 2 pi.
2 pi. And if we went backwards, it would be the same thing. I go backwards a whole jump. It would be
Okay.
the same thing. So here's how we're going to write this. We're going to take our 4 answers from before, and we're going to write plus 2 pi, because 2 pi was one trip around the circle.
Right?
And we're going to do it in times. So we're going to write times 2 pi times n.
And what does n stand for?
N is a natural number, or an integer actually.
Oh, so
Which
just
would be
a whole number.
Negative 3, negative 2, negative 1, 0, 1, 2,
Ah.
and so forth.
So that's
okay?
just saying we could do whole number circles.
Whole number circles. You have to go around the unit circle that many times, and you have to do a whole trip. If it's a positive trip or a negative trip, you have to do an entire trip around the circle.
Well, that's easier than listing all
So
infinitely many.
all we have to do then, literally, is just add plus 2 pi n to every one of these answers,
And we're done.
and we have covered all infinite solutions.
Okay, so if it says all, we have to add all our trips around the circle.
Absolutely. Now, are there other ways to generate pi over 4, 3 pi over 5 pi? Sure, there's
Yeah.
creative, cute ways to do this.
This is the easiest.
We're not expecting you to do that. That's basically the idea.
This is the easiest.
We want solve for the ones around the unit circle, and literally all you have to do is add plus 2 pi n, and you will have covered your bases. If you check answers somewhere in the book, which you probably don't do because we don't use the book very often, it'll have a cuter way to write some of these. But for now, for us, this is our expectation level. That's what we want. If we get there, we get high fives, balloons, and streamers for everybody.
Woohoo! Okay, I want to try one.
Okay, you try
Let me
one.
see if I can do one here. All right. So we need to find all the answers, which just means in the back of my head, when I get my answers, I'm going to add something to it.
2 pi
So
n.
let's keep. Thank you. Let's keep solving. So I've got 2 cosine squared x plus cosine x. But I have a cosine of 2x over here. I really want that to be an x. Now cosine of 2x was really 3 different identities. It was the cosine squared of x. You see, I volunteered to pick the harder one.
Nice.
It was
Minus
minus
sine
the
squared
sine
of
squared
x.
of x. It was
2 cosine squared of x.
so what he said.
Minus 1.
And
And it was 1 minus 2 sine squared of x.
Sine squared of x. Okay, so if we look at our problem and realize that these are all cosines, then I probably don't want to deal with this identity at all.
I don't want to deal with the first one either.
I don't want to deal with the first one either.
I don't want to bring in extra trig functions that I don't already have,
Nope.
if possible.
The best thing, and you'll notice on your notes if you actually read them, is one of the hints is, if at all possible, get one trig function. So we're gonna change this to be 2 cosine squared x plus the cosine of x, and then we're gonna have that equal 2 cosine squared x minus 1.
I kind of like that.
I really like that. And do you know why I really like that?
I know why I like it. Why do you like it?
Because if we go and subtract to get everything on one side and have it all equal to 0, or I'm just going to start with a cosine squared actually. If we subtract our 2 cosine squared x, guess what happens?
They're gone.
Bye, see you later. Have a good day.
We don't have to deal with them anymore.
Okay, well now I have that the cosine of x is equal to -1. So I was starting in my brain to get everything to equal 0, but I don't have to do that because now I already have my cosine of x by itself.
Sweet.
So where in my unit circle is the cosine equal to -1?
How about pi?
How about pi? I like pie. Chocolate pie tubes, to be precise. All right, so it only happens once on one trip around the circle, so it's at x equals pi. But Mr. Leckie said just a minute ago that if it says all real solutions, then I simply have to go
2
plus
pi n.
2 pi n. So you mean that's my answer?
Yep. If you want to be really perfect, you'd write n as an integer, but
We assume that n is an integer.
we will make that assumption.
Yeah, if you want n to be anything else, you let us know.
All right.
Okay.
Your turn. I'll do it.
I want to make him factor some more.
Sweet. Here, you have the paper.
Okay, I got the answers.
We have 4 sine squared of x minus 4 sine of x plus 1 equals 0.
Yes, we do.
No double angles, no weird stuff. X is inside, all sine functions, so we can go straight ahead and solve this.
Yep, we just need a factor.
This is more like our ax squared plus bx plus c, so we're going to make a box. And you changed the letters last time. I'm going to go ahead and just make my box with sine functions in it. Is that okay with you?
Okay.
All right, so we're going to go over here, and this is just in case you don't want to change all the letters. We're going to have 4 sine squared of x in the top left of the box.
Well, and actually, time out. What we should say is that they could actually pause the video right now and try it themselves.
They should. That would be
Pause
even
it,
cooler.
give it a try, and then come back and check your factoring with Mr. Leckie. Make sure he's right.
So the both of you that are watching this right now, go ahead and pause it, and we'll talk to you tomorrow. Okay.
Okay.
So here we go. 4 sine squared of x, we got plus 1 on the bottom. We need ACB kind of thing, and we're looking for numbers that multiply to make 4 and subtract to make, or add to make -4. Any ideas?
Apparently, I don't have any ideas.
How about
2 and 2?
How about -2 and -2? How's
Negative
that?
2 and negative 2 is even
So
better.
we have -2 sine of x and -2 sine of x, so that when added together, they make -4 sine of x here. And we're going to take out our greatest common factor of our first row, which is
2
going to be
sine of x.
2 sine of x. And 2 sine of x times 2 sine of x makes 4 sine squared of x.
Yes, it does.
And 2 sine of x times -1 makes -2 sine of x.
Yes, it does.
And 2 sine of x times -1 makes -2 sine of x.
And hey, -1 times -1 is 1.
And that works, so we're happy.
Yay.
So our factors are simply 2 sine of x minus 1 times 2 sine of x minus 1, which means we get a multiplicity of 2 again. Why do I keep getting these? Okay. But that means that 2 sine of x minus 1 has to equal 0.
And since it's the same thing, do we really have to solve it twice?
We don't have to solve it
Okay.
twice. This is the same thing, so there you go.
How about the sine of x is a half?
So we add 1, divide by 2, and we ask ourselves, what did I take the sine of to get a half?
30 degrees or pi over 6.
Pi over 6. Anywhere else?
Oh, wait,
On
sine
the
is
unit circle?
positive in the second quadrant.
We go ASTC.
Look, I got it right that time. It's a sine in the second quadrant.
There
How
we
about
go.
5 pi over 6?
5 pi over 6. And we would like to adjust this for every possible solution in the world, which
Plus 2 pi n.
we can do simply by adding 2 pi n to both of our
Ta-da!
answers. We are done
We are done.
completely with solving trig functions.
We are amazingly done. Like, completely done with the video.
Very cool.
That's it.
We may even break this into just part of the test only, won't we?
Yeah, I'm thinking just calculate, or non-calc would be great.
Very cool.
So.
So be prepared for a little review in class coming up soon, and then a test coming up on the first half of chapter 5. And we'll cover the nasty parts of the calculator part on the second half of chapter
On
5.
the second half.
All right, but that'll
All right.
do it for today.
We'll see you in class.
Bye-bye.